Hello, everyone, and welcome to the Premier Project presentations in the 2021 cohort of the Hamoye Data Science Internship. I am Sophia Jack Udechuku, a data scientist at the Hamoye AI Labs, joining this call from Port Harcourt, Nigeria. The internship itself has been an intense period of studying. Here, learning takes a rather different shape, and we like to use the phrase learning by doing. That is why over the past weeks, our interns have had to work on real-life projects. Our interns are ready to showcase their knowledge and to impress our amiable judges, Hamoye fellows, and members of the data science communities here present. And personally, I can't wait to be blown away. I would like to, in a very special accord, acknowledge the presence of our judges, who are members of the Hamoye AI Labs. Zalihat Mohammed, you're welcome. Thank you for joining. Rudolph Jane, you're welcome. And Basil Ihoma, welcome. Thank you for joining. And our Hamoye fellows who have come to show their support to our interns also, you're all welcome. Thank you for joining. Before we switch focus to the presentation, please let's take note of the following housekeeping and proceedings. If you're a presenter for any of the groups, do ensure to use your full name as your Zoom display name. This is to enable us to identify you easily and grant you screen sharing permission. Please use your full name as your Zoom display name. You can post comments and ask questions and share how you feel on the chat boxes on Zoom and on YouTube. If you need to speak, please raise your hand and you'll be unmuted. For the presenters, you have only 300 seconds, which is 5 minutes to do your presentation. At 2:40 seconds mark, I'll notify you of how much time you have left. Please be precise and concise, I'll advise you. After your time is up, the judges may ask questions as they please, or they offer their recommendations at the end of all the presentations. Please take note once again, you have 5 minutes to present. 4 minutes, I'm going to remind you, and then 5 minutes on the dot. Please, you need to hand over to the judges to make their comments. So now to the presentation. The first group to be presenting is Kera's group. I hope you're ready. Oladimeji Williams. Oladimeji Williams.
Yeah, I'm ready.
All right, please go ahead with your presentation. You have 5 minutes.
Good day, everyone. Oladimeji Williams is my name. The title of my project is HR Analytics Classification. It is a supervised classification problem undertaken by Team Keras. These are the names of members of Team Keras. We have to build a model that correctly predicts if an employee is to be promoted or not after an evaluation process. The model should also be deployed so as to be able to make live predictions. But how are we supposed to go about it? The model flow process is a good guide. It starts by data collection, then prepare, clean, and fix null values and outliers. We then proceed to training several models, validate and evaluate the models in order to pick the model that performs best. We then finally deploy the model. We got a near perfect data for this problem on Kaggle, and here's the link to the data set. This is a list showing the variables in the data set against their respective data types. As it turned out, there is no variable that can be said to have outliers relating to this project. The reason behind this assumption is illustrated in this visual, showing the box plot of the age variable. This plot tells us that there are outliers between the ages of 55 and 60. However, we all know that the retirement age in some countries is 60 and not any younger, at least here in Nigeria. So we're going to truthfully say that this is an outlier. Hence, we include all these variables. Next, we inspect the frequency of employees' gender by the department. And we can see that the most popular department is the sales and marketing, housing most of the male employees, while most of the female employees are in operations department. We also inspect the frequency of the promoted employees by the level of education. Here, we can see that most of the promoted employees have bachelor's degree, and the result is corroborative evidence that the training data set is a near perfect data set for this project. Now, using a heat map, we inspect the contribution of each of the variables to determining whether an employee would be promoted or not. Looking at the last row here, we see that about 3 or 4 variables have significant level of contribution. we can see that the KPI is the major determining factor with a contribution level of about 22%. However, there is a potential danger of multi-collinearity due to the high correlation between age and length of service and between KPI and previous year rating. So this helped us to reduce our final values from 12 to 10. Next, we inspect the performance of several common classifier models on the training data sets, and we decided to build a base boost classifier model, which has an accuracy of 94%. However, we are more interested in having a high recall value and not accuracy. So we decided to further evaluate the performance of the card boost, and we discovered that this model performed poorly on our interest, having a recall value of just 53%, but with precision of about 95%. This means that it is predicting many more people to be promoted, which is a trade-off as regards this project and could be detrimental to the company. This is obvious in its confusion matrix, where it is having a conspicuous 446 false negatives with a very small 260 false positives. So our goal is clearly defined: to reduce the false negatives to the barest minimum whatsoever. So we decided to perturb the training data set using some classical techniques such as oversampling and undersampling, and to evaluate the performance of random forest classifier model on the training data set. And we're able to achieve 65% recall value. Here, we see that the random forest classifier model generates a reduced 250 false negatives and an improved 456 false positives. That's a little more than 50% performance increase when compared with the initial results. This means that our model would be stricter than the other models for those who would be promoted. Next, using Flask and Ginger frameworks built on Python, we deploy the model on Heroku, and here's the link to the model to make live predictions. This is the interface of the deployed model on Heroku, including the description of the final features. This is a demo of some of the predictions made. While trying to make predictions, it is important to remember that a value of 1 in the KPI field means the employee meets his target KPI, while 0 means he or she does not. So since the KPI is the major determinant, if an employee does not meet his or her target KPI, he or she is not supposed to be promoted. But if he or she meets his or her target KPI, along with other variables, he should be promoted. And that's exactly what our model predicted. So having used different models, we clearly see that the random classifier model proved to be the best at achieving the goal of our client by correctly predicting the staffs to be promoted. Thank you so much for the opportunity.
Thank you. Over to our judges for recommendation or question.
Okay, so my question will be that as a business owner, right? For example, if I want to adopt your model, do I have to bring my own data? Because I don't know if it is generalized. And how do I know the confidence of your prediction?
Yes, you don't have, number one, you don't have to bring your own data. You just have to insert your data. In fact, you can test it on the internet right away. It's on that link there. So when you input some of the values and some of the features, the values of some of the features there, it's going to tell you that whether the staff is to be promoted or not. The initial model that we designed, we were looking at the accuracy. So we discovered that it was having so many people to be promoted. So, but then we thought about it that it would be detrimental to the company if many of the staffs are being promoted. So it's now very stricter to those who will be promoted because of.
Sorry. So I just want to know, like, how do I test the confidence that in just one sentence? How do I test the confidence? So, for example, I can say, okay, I'm 90% sure that this person should be promoted. I don't know if you get my question.
Yes, I understand, and we have statistics. Like, we used the recall value, and it gave us 65%. So a quick way of checking without looking at the statistics is
in one sentence.
Looking at the confusion matrix, it tells us the confidence of our model.
As a user using the interface, I don't have access to that.
As a user, you look at the KPI field. So most importantly, if the person does not meet his or her target KPI, is not supposed to be promoted.
I think I'll just drop my recommendations and other things on the sheet and then to be sent to you. Thank you.
All right, thank you.
All right, thank you, Zaliha. Thank you for that presentation. The next group is TensorFlow. Samuel Ose and Samuel Taiwo Omole. Are you ready? TensorFlow group. Samuel Ose and Samuel Taiwo Omole. Okay. If I don't get any response, I will go to the next group.
I'm ready.
All right. Please go ahead.
Okay.
Time starts now.
Hello?
We can hear
Hello?
you.
Okay, this is Samuel Omole.
Okay.
This is Samuel Omole, TensorFlow.
Please go ahead and share your screen.
Okay.
Okay, no waste time. Get this time. Share screen now.
Bringing my screen up. Sorry.
I get in part now, you don't dey focus.
Let's get ready. Psychic Leg. Olani Ron. Oluwasegun Emmanuel. Please get ready. Samuel, are you ready for us?
Hello? Samuel.
Is the next group
Hello?
ready? Okay.
Can you see my screen?
Yeah, this is it.
All right, you can
Yeah.
see us. Go ahead. Please.
Oh,
Okay, I'm Samuel Ose, and this is TensorFlow group. So our problem is to try to solve the insurance project. So the problem is our client wants to know if someone will be interested in insurance, someone that is interested in health insurance will be interested in vehicle insurance. So the solution is we actually collected data from cargo, and we're able to build a predictive model around the data and also derive some meaningful insights from it. So first, our data collection processes was that we fetch data from cargo, we downloaded the CSV file, then we found out that it has features like gender, age, number of years, the vehicle ownership, and level of insurance, level of health insurance. So this is the first 5 rows of the data. The data contain about 381,000 samples. And we noticed that the data set is highly skewed, meaning that we have very high observations that are not interested in vehicle insurance. So actually using accuracy, if I show you the graph, you'll see that 87% of all the policy holders were not interested in vehicle insurance, while about 12.26% were actually interested. This shows that the data is highly skewed, and using accuracy as a metric to evaluate our model would be very, very biased. So we actually decided to use other metrics like F1 score, precision score, recall score, and Martin correlation confidence. So this is a potency table of vehicle damage. It shows that 49% of all policyholders with no vehicle damage in the past were not interested in the vehicle insurance, while about 0.26% of all policyholders with no vehicle damage in the past were interested in vehicle insurance. This also shows that in some readers, if someone is interested in vehicle insurance, the person is likely to have suffered from a vehicle damage in the past. So that is a very key observation in our analysis. Now, if I scroll down a bit, you see the distribution of age as it affects the probability of being interested in vehicle insurance. So if you look at the graph, you see that ages from about 20 to 34 are less likely to be interested, while about 40 to 50 are more likely to be interested in vehicle insurance. You can see that it approximates a standard normal distribution, while the other one kind of is skewed to the left. So this is also an important observation in our analysis. Looking at the box plot, you can also see the mean age of someone that's interested in vehicle insurance is about 43, while the other one is about 38. So you can see the disparity between the both of them. This just means that if someone is younger, the person is more likely to be uninterested in vehicle insurance. Now let me display the feature engineering phase. Now, as I earlier said, data set is severely imbalanced, and as such, using accuracy will not be a wise decision. So we actually use precision, we call F1 score and multi-correlation coefficient. We also did some sampling techniques such as random oversampling, random undersampling, and synthetic minority oversampling technique, which is also known as smooth. Now, random undersampling is just taking the minority class and projecting it to become the same shape with the other class. You can see the picture down there. The minority class is just projected to be the same shape with the data set. Undersampling is just trimming down the majority down to the shape of the minority class. While smooth is basically using k-nearest neighbor to calculate distance in order to synthetically project and produce new examples to cover up the feature space. Now, we feed the model on the data and we're able to get this confusion matrix. So we actually noticed that the model was kind of biased to people that were not interested in vehicle insurance. So with a little bit of code, we were able to increase the precision score and also improve the model performance. So we did some hyperparameter tuning and we got an accuracy of about 85% precision score and recall score of about 33%. Now look at, let me show you a demo of the project. Now we created a Streamlit application to display the project for end users. So you can see you have some attributes, some features by the left. So adjusting those features will actually give the probability of being interested, which is about 0.26 now. Scroll
We
down
can't
also,
see
you
your
see
screen,
that also,
sorry. We can't see your
you can see my
screen.
screen.
Yes,
You
I
can see
don't
the
know if
screen.
it's
I'm trying to show the demo of the project. Hello. Can you see my screen?
You have 30 seconds left.
Okay. In conclusion, we actually say that if advertising vehicle insurance to health, if advertising vehicle insurance to health insurance is very, very expensive, then we optimize the model for precision because we want to be sure that they should be interested. This means that if we are actually interested in actually getting people that are interested in vehicle insurance, we will have to optimize for precision so that we not waste customer time by giving them ads that they're not interested in. But if you want to get all customers that are actually interested, we might want to optimize for recall. And a naive model would just predict that everybody is interested. So I think optimizing for precision would be a better alternative than recall.
Yeah. All right. Thank you for that presentation. Over to the judges, please.
Hi, Samuel. So I like the fact that you decided to use the precision and recall to measure the accuracy of the model or to to evaluate your model instead of optioning for accuracy. But then I want to understand, what model did you use to train your data? I don't think you said anything about that. And
Okay.
did you just use one model or use some couple of models and then compare to know which of them did quite much better? Go ahead. I can hear you.
Okay, I use a Gaussian MB. Hello, can you hear me?
Yeah, I can hear you now. Go ahead.
Okay, I use a gradient boosting classifier, random forest classifier. I also use decision tree classifier. I use Gaussian naive Bayes, and I use Ada boost classifier. So out of the 5 of them, gradient boosting classifier was the best. And I also consider some trade-off like speed. Gaussian MB was faster, but was producing lower recall score compared to a gradient boosting classifier. So I took a trade-off and went for gradient boosting classifier. Did some optimization. I was able to get the best model for it.
Okay. Did you show that in your presentation?
Yeah, it's not on my presentation right now, but
that brings me to like the second, not like a question, but like a recommendation. I mean, you did a very nice work and you kind of adopted like some good practices, more like, evaluation of the model and then how you handled like both oversampling and undersampling. But then when you are presenting a project like this, I think it's very important that the way you relay the information or your findings via the presentation should be very visually appealing So in that case, your PowerPoint slides, they were not like giving me like more detailed information of like everything you did. I understand that at the time you slide into another window to give us a presentation, but then I think we are not able to see that. It's good that it's of good practice that you put everything into your stuff, more like a detailed summary of the whole work in your slides, so that like you'll be able to communicate the information to us so we can understand what you did. But yeah, nice work, though.
All right.
All right, but
All right. Thank you. Thank you, Basil. I hope you got that recommendation, Samuel. We seem
yes,
to
yes.
be all right. So we're going over to the next group. Scikit-learn, Olaniran Oluwasegun Emmanuel. Scikit-learn, Olaniran Oluwasegun Emmanuel.
I'm not prepared for this now. I want to just to talk about the deployment.
If you're not presenting, please mute yourself if you're not presenting. Thank you. Olaniran Oluwasegun Emmanuel. Are you here? All right. Please, this spy group, get ready.
Okay, good afternoon, everyone. I'm Alani Oluwasegun, the group lead for Scikit-learn Group, and we'll be presenting Olympic Games. These were the members that we did the group together to achieve the success of this project. So, Olympic Games are leading international sports where different countries come together to showcase their skills, and based on different sports, the winners will be given medals, which are gold, silvers, and bronze. So our project is just to predict the country that is likely to win medals. So these were the methodologies we use. We use the data acquisition, data cleaning, exploratory data analysis, feature engineering, splitting, and model evaluations. We got our data from Kaggle, and these data sets are broken into two: the summer, winter, and dictionaries. So here are the features and the descriptions, the countries, the code, populations, and so on. Then these were the libraries we used in order to achieve this project. Now data cleaning. We had three data sets: the winter, summer, and dictionaries. So for we replaced some duplicates in the discipline with columns, and from our analysis, we noticed that the Summer Olympics started in 1896, and it was cancelled in 1916 because of World War One. It was also cancelled in 1940 and 1944 because of World War Two. Then for Winter Olympics, it started in January 25th, 1924. From our analysis also, the Winter Olympics and summer was held for 4 years. But from 1994, Winter Olympics started years every two years. So from the summer data set, 147 countries participated, 22 cities hosted the Olympics. We had 43 sports, 59 disciplines, and 66 events. Then for winter also, we have 45 countries that participated, 19 cities, 7 sports were done, 15 disciplines, and 83 events were taking place during winters, all to get these medals, either gold, silver, or bronze. Then we saw that the highest medal, the highest medal was Michael, and the female was Lithuania in for the Summer Olympics. Then the Winter Olympics was Ole. He had 13 medals. He's from Norway. And the female was Stefana. She had 10 medals. Then from our analysis, we also saw that during during summer distribution, we saw that male has 73% than female. Then during winter, we saw that male has 58%. During winter, we had male has 68% and 31%. Then the flow based on the year for female, during summer, there was a rise in 1980 for female distribution. Then for male, there was also a rise for female rather in summer. There was also a rise in 1952. Those were the experimental data analysis we saw. Down during feature engineering, we did ordinal encoder. We split our data into 80 and 20%. 80 train and test with the 20%. We did our model training and validated our model. Then we evaluate our metrics using F1 score and precision. Then we also do another iteration where we use label encoder. We split the data into 80 for training and 20% for test. We did our model training, we evaluated them using F1 score and precision. For the first iteration, we used those summer data set and we used over 10 models. And random forest came as the best model, having 0.7 score for F1 and precision. Then for winter, random forest also had the best, which is 0.6 F1 score and precision score. For second iteration, we had label encoder. We use label encoder. Bagging classifier as the best out of the 10 models we used. So these were the model we used for first iteration. And these were also the model we used for second iterations. And here are the feature importance chosen by these models. From our conclusion, we saw that bagging classifier as the best when we joined the two data, which is summer and winter. And AI can also be used in Olympics to understand the country that is likely to win. That's what we concluded. Thank you.
All right, thank you. Over to you, judges.
So a nice presentation. I just have a couple of questions for you. Does this model also cover Paralympic Games?
What did you say? I can't hear you.
Does this model include Paralympic Games as well? Like there are Summer Olympics, Winter Olympics, and then Paralympics Games.
Parallel.
Okay.
No, he means Paralympics. That's
Okay. No,
yeah,
not Paralympics. No.
Okay.
It's not Paralympics.
And like, how did you end up like using these features only? Do you had an like research like are these features enough for predicting like whether the country will win a medal or not?
From the data set, we used the city, the country, sports, athletics, the gender, and the events.
Okay. While if a country can win, there may be other factors as well, like the performance of the player who is nominated and other things. So, do you have like those features also included, like, or do you have any plans for that?
We didn't do that. We didn't put that into consideration.
Okay. The model you have trained, like, have you created a deployed version of this as well, or
No,
is it just?
It's just model building, not deployment.
Okay. Okay. And just last one, can you explain that part when you have accuracy and precision, the confusion matrix you made? Yeah. So how did you end up like with what is the relevance of F1 score over here?
It's F1 score and precision we use for the metrics evaluations on our models, where we had 0.7
was there any problem of minority class over there?
For gold has more capacity than other medals.
Okay. Okay, then that's all from my side. Thank you so much.
All right, thank you, Gaurav. The next group, please. Sayak Malik and Godspur Ibole. Hope you're ready. While they start presenting, ML Park, please make sure you get ready. All right, go ahead. We can't hear you.
Godspar, are you here? Are you presenting? Okay. He's muted. You have to unmute yourself, Godspar. I think he's unable to unmute himself. Shall I go forward then, or will I wait for?
Okay, go ahead, please.
Okay. Fine then. So this is the problem statement that we had. Okay, good afternoon firstly, and this is the team FISP. And we were given a data set on limiting airplane crashes. So firstly, the problem statement that was given to us was that there are a lot of air crashes happening, right? So we wanted to know with the use of a data set, what are the main reasons for these type of crashes and how to sort of, try to avoid them as much as possible. So we tried to look at an article from NATLA review that sort of said that the most common reasons are pilot error, mechanical failure, and poor weather. And we sort of wanted to check if these are the right causes. So our goals were basically to investigate the data set and to make to observe some patterns sort of. So we found the data from Kaggle. The data set contains informations about fatalities, people aboard, date, time, operators, and people killed on the ground, right? So what we wanted to do after that is we did data profiling. Firstly, we did a sort of exploratory data analysis, and we did some feature engineering also. And then we used a machine learning model to try to find inferences. Since it's our first presentation, we couldn't actually deploy our model, but we hope you'll understand. Okay, so moving forward, we actually cleaned the data. There were some columns which needed cleaning, were filled with wrong data sort of, and we dropped them or sort of used the fill in a function. And then we tried to look at visualize the properties, the relationship between the sort of the properties aboard, fatalities, and ground, which are the sort of the deaths, right? So we sort of created a heat map for the same, a correlation heat map. And now we move to the exploratory data analysis section. So here we plotted total airplane crashes per year, like over the years, right? So we noticed that it has spiked somewhere around the 1960s to the 1970s. And we can also see that because there were a higher number of airplane crashes, the number of fatalities has also been highest near that region, right? And also we can see recently there has been a decrease because maybe we can say we are getting better at not crashing airplanes. We are avoiding it more and more. And also consequently, there have been less number of people dying, right? So also the total number of people aboard airplanes per year which have crashed, that we can see is again sort of highest near the 1970s. And this one's an interesting graph. This one's the fatalities survived and killed on ground per year, right? We graphed it over the year. And here we notice there's a huge spike somewhere near the 2000s for the ground, the total deaths on the ground. So this exact crash had a lot of deaths on the ground, but not so much like, of course, there were some deaths on the flight itself. So we wanted to know what this is about. And we found out that this one was the dreaded 9/11 crash. Yeah. So, okay, moving on. We found total fatalities by operator. So we wanted to find out which operator was more susceptible to sort of crashing and had a worst record. Yeah. So we found out Aeroflot sort of had the most number of deaths as well as the most number of crashes, which is sort of natural since we found that they have a high correlation. Yeah. So we can see that Aeroflot has the highest number of crashes and one should watch out for them, yeah, when ordering for the next flight. So I want to ask if Godspar wants to take over, if his mic problem is okay, or I shall continue. Shall I continue then?
You can continue.
Okay, then I shall continue. Fine. So then we sort of wanted to, there's an interesting column in the data, which is this summary. Yeah. So it provides a short summary of how the plane sort of crashed. Some of these rows sort of had NANs, but we sort of removed them and we are sort of looking at the ones which have some sort of data. And we wanted to use it to form a sort of clusters to understand the different reasons why a plane can crash. Yeah, so we've dropped the empty rows, did some features extraction using TF-IDF, used the TF-IDF vectorizer to implement the sort of algorithm. And then, interestingly, we found top 5 clusters, which sort of gave us the rough reasons why planes are crashing. Yeah. So the first one, we found that these were during takeoff. The second one was during landing. The third one was due to crashes due to the engine failure. The fourth one is due to weather conditions. And the fifth one is also relating to takeoff. So we can see clearly that 2 of the causes which we saw in the review, which we have in the article we have linked above, which is mechanical failure and poor weather, can clearly be seen in the clusters here. And the third one about pilot error is not clearly visible because of in our clusters, the sort of clusters we have taken, but it can be because that it can be during takeoff or it can be during the landing that these sort of pilot errors might have happened. Yeah. So based on this data analysis, we found that most of these crashes can be investigated with the reasons that we have listed here, more or less: mechanical failures, poor weather, and some sort of error by the pilot himself. So from this, we have proposed some short solutions. A few of them is reduce flight in poor weather conditions to avoid that sort of problems. Some sort of checks, frequent checks to make sure that there is no mechanical failure. Everything's okay with the flight before before flying. And then also there should be adequate care taken for the flight operators, and the operators which are not performing well might be, sorry.
Your time is up, please.
Okay, I'll just conclude 1 second. Okay, so that's we should take care about the operators, yeah, and we should train the pilots also efficiently. So the challenges we faced, a couple of them, some missing values in the data.
So thank you very much. I'll just ask my question now. So
yeah, sure.
So are you treating this problem as an NLP problem, and why did your data stop at 2000?
Okay, I'll just NLP problem. Yeah, it is being presented as an NLP problem because we didn't know where else to use a machine learning model here. We've performed a lot of exploratory data analysis to find the reasoning, sort of. But then we noticed this summary column, and it provided a lot of further information that could be extracted, right? So we used NLP. And the second question, I'm sorry, I didn't catch you. Hello.
Okay, so I was asking about the data. Like, what's the last date you have?
What is the last date we have?
Or yeah, like, is it recent? What's the last date you have?
Yeah.
Is it yesterday or?
No, it's not yesterday. It was a data we've picked from Kaggle. So it's sort of not up till yesterday, but it's sort of like till the last year around, I guess.
Oh, okay. And why did you use just one model?
Okay. So most of us are beginners in our group, and we wanted to do the exploratory part really well. But since we noticed that the summary column can be used well, one of us was aware of how to use it for NLP using k-means clustering, and hence we went forward with the approach. Yeah.
All right. Thank you.
All right, thank you.
I'll drop my suggestion.
All right, thank you, Zalihat, for that. The next group, please. Eyene Rudolph and Aliu Saludin. ML Park. Eyene Rudolph and Aliu Saludin. And the next group should get ready. Pandas, Chukuma Anthony. Please get ready. Thank you. Go ahead. Rudolph, we can't hear you. Please unmute yourself, Rudolph. Hello, Rudolph. We can't hear you. Is Aliyu there?
Can I have a team member share their screen so that?
Sorry. Good afternoon, everyone. This is Amaba talking, a member of the team. We had that issue yesterday, so I would like to get a co-host request so I can share my screen, please.
Oh. You're a co-host now, please.
Yeah, oh, thank you. So I'll be sharing my screen now so she can use mine. All right.
Your time starts now.
Yeah, thank you very much, ma'am.
Okay, so for our project, we focused on the aviation industry, and we took a look at airplane accidents, and we wanted to find out, discover trends, discover patterns, to derive insights that can help us make informed decisions, as well as help us to steer the direction of further research. Please keep moving. So the core aim, the next slide. So the core aim of our project was to derive insights, like I said, to analyze our data and to derive insights and patterns and trends from the data that we got. Our data set was gotten from Kaggle. Next slide, please. Our data set was gotten from Kaggle, and it covered airplane accidents from 1908 to 2021. Our project was mainly an exploratory data analysis, and we communicated our findings in charts, graphs, and pie charts. Keep moving. The first analysis we did, yes, next slide. First analysis we did, we took a look at the occurrence of accidents by decade, and we discovered that there was an increase in the number of accidents that occurred starting from the 1910s up until the 1950s. It reached its peak in the 1950s, and we discovered that the 1950s was a decade marked by the post-World War II. Moving on, we also zoomed in on the occurrence of accidents per year, and we discovered that 1946 recorded the highest occurrence of airplane accidents. We noted that there was a significant increase in the occurrence of accidents from 1940 up until 1946. And we checked and we discovered that that was a period marked by World War II. We decided to do an even deeper look and observe the occurrence of accidents per month, and we discovered that the months January and December had the highest. December and January had the highest occurrence of accidents, highest and second highest occurrence of accidents, respectively. Keep moving. We did an analysis on the occurrence of accidents per day of week, and we discovered that apart from Monday and Sunday, all days of the week had an almost equal likelihood of housing an airline accident. We took a look at the occurrence of accidents on weekdays to weekend, and we discovered that more accidents occurred on weekdays as opposed to weekends. And we noted that that could be due to the fact that more airplanes are carried on weekdays as opposed to weekends. Keep moving. Total fatalities per year. We discovered that the deadliest year of air travel was 1972, with fatalities amounting to about 2,796. We took an even deeper look at the year 1972, and we discovered that there were about 77 airline crashes. We also took a look at the analysis of occurrence of accidents on the basis of countries, and we discovered that the United States of America had the highest occurrence of accidents. We noted that that could be due to the fact that the US has the most airplanes as well as most airline passengers carried per year. Keep moving. We also wanted to take a look at the occurrence of accidents by aircraft operate by countries. Yes, we wanted to take a look at the occurrence of acts of accidents by countries in the 21st century, and we noted that the US still maintained its position as the highest country with occurrence of accidents. Keep moving. We took a look at analysis of occurrence of accidents on the basis of aircraft type, and we discovered that Douglas DC-3 had the highest occurrence of accidents. We also noted that other aircraft types had an accident occurrence below 50. Keep moving. We also took a look at the occurrence of accidents on the basis of aircraft operators, and we noted that Aeroflot had the highest occurrence of accidents. And Aeroflot is a Russian airline, and it had about 253 accidents from our data set. Keep moving. We decided to look at the occurrence of accidents based on military versus private operators, and we noted that we had more accidents occurred due to private operators than military operators. Keep moving. Keep moving. Next slide. We took a look at the proportion of fatalities to people aboard, and we noted from our data set that there was a significant increase in the survival rate of passengers starting from 1945 as opposed to the years before 1945. So keep moving. We also noted some of the key takeaways that we made from our exploratory data analysis was that 1972 was considered the deadliest year of air travel with total fatalities of about 2,796 and 77 airplane crashes. We also noted that the United States of America had the highest count of airline accidents from 1908 to 2021. We noted that the safest year of air travel in the 21st century was 2017. Okay. Thank you.
All right, over to the judges. Thank you for that.
Thank you for the presentation. First, I would like to commend you for the work done and the charts you used in relaying the information. I think it was well detailed. Then my question, can you go to slide 8, please? The 8th slide, please. Yeah, so I noticed that in the second quarter, there seems to be like a decline in the number of flight accidents. And then there is a sort of a sudden increase from the third quarter to the fourth quarter. Do you know why that is, please? Did you get my question?
Sorry, can I answer that? This is
yeah, go ahead.
Okay.
We believe it is due to the fact that when it is close to this third quarter of the year, people tend to travel more because it is close to summer. Like that's where we have summer.
Okay,
Hello?
okay. That's fine. That's okay. Nice work. Thank you.
All right, thank you, Basu. The next group, please. Pandas, Chukuma Anthony, and Victoria Udo. Are you ready? While Optuna group gets ready.
All right. There's Victoria waiting on you, please. Miss Victoria, you can go slightly. She says she can share her screen, please. Would you guys make her the co-host, please? Victoria, Michael. All right. Good afternoon, everyone. Good day, everyone. We are presenting on behalf of 18 points. I am Victoria. I'll try to plug the screen so start. Okay. Hope my screen is visible to everyone. Okay.
Yes.
To everyone, as I said earlier, we are presenting on behalf of Team Pandas and my partner, Dora Michael Ludo. Our topic is generally predicting appropriate prices on rental properties. And we all know real estate is just basically you trying to get the best out of whatever property you own. In this case, dealing on rental property areas such as Germany in Germany. So our data set, we obtained our data set from Kaggle. So the problem we're trying to solve here is most clients or most residents are trying to get the best out of the property. Like that is if you want to rent the property, how do I know this is the best place for me to get with the amount of money I have at hand? So that's what this is basically trying to solve. So our aim is to figure out what areas had an increase in rent, figure out what areas are expensive in case if you want to live the high lifestyle in Germany, a place to do that. And what areas has the highest increase and decrease in rent. So as I said earlier, our data was built up from Kaggle. These are the links, the data sets. So during our data set collection, data set collection around between these days, as you can see up here, and during the data cleaning, took out some empty values, some empty columns that we have. So that says I also took out some we're having 2,840 so just have to get this or sync it. I'll go to my partner to go ahead to continue the presentation. Thank you.
Good afternoon, all. Well, like my partner said, we first of all dropped columns, and the next thing we did was for the relevant columns which we needed, some of them also had null values. So what we did was for the categorical values, we autofill them with the mode, and for the numerical values, we used the interpolation to autofill them, and for our visualization, we used the matplotlib. And please, next slide. Okay, we are able to group this data set into 16 cities. So that means we are working on 16 cities to know the exact price range of the houses and the condition of those houses. Next slide, please. Now, from our visualization and everything we did, we see that the rent prices did not increase over time. Rather, they were steady. There was a steady increase. Like everything was within a particular range. Saying that at some points they are high and at some points they are also low. Next, okay. And then for the region with the most expensive house pricing, we see that the very first one, the Northern Westphalen, had the highest prices. So anybody who needed a house, if you need expensive houses, that was the most expensive region. And for our least expensive region, the cheaper region, we see that Bremen here had the least expensive region. Next slide, please. Now, to see the area that had the largest increase and area that the houses went cheaper during that specific period, we see that Berlin had the highest increase in housing in the rent price, and then the Sachsen-Anhalt region, that it had the least. It became cheaper over time. Next slide, please. Now, in conclusion, like I've said, the rent price was within a range. It did not have any steady increasing trend. And Berlin had the highest increase. So whoever was looking for a house in that area, or whoever had a property for sale, or whoever needed a place to stay at that period, depending on the person's financial capability at that time, if the person needed a very high rate of, if the person needed a house that had a high price, and a house that was for people with top class and top quality and everything, Berlin had the highest, and Sachsen-Anhalt had the least. Now, one thing we were able to see when we conducted, we used our heat map and correlation and everything. We saw that some features, such as the size of the living space and the year constructed, had strong correlation with the base rent. That means the size of the house, the year it was constructed, if it's a brand new house or if it's a refurbished house, they all had a strong correlation. So they affected the base rent of each of these houses. So whoever is looking for a house, whoever needed a place to stay, whoever needed a place to rent, if it's a very big house, you see that they had a higher rent price. And also if it's a new house, it was also high. So this is what we're able to get. So thank you for listening.
Thank you for that presentation. Over to the judges.
Okay. Yeah. Nice presentation. Just a question. So, like you said, you dropped off the null values. So, have you checked? Like, might be possible they had some relevance, or they might be affecting the price chart.
Well, the data we dropped, columns we dropped, we ensured we're not used. Those were just inappropriate columns we did not need for this particular project. For instance, columns like if the house, they allow pets inside, that does not, allowing pets does not really affect the price of the house, the rent price. And some had, does it have a, okay, we use the kitchen parts, we used some of those things just did not really have relevance. So we dropped what we knew did not have relevance and only used what had relevance to the project at hand.
Okay. Just last thing, this is an analysis task, right?
Yes, sir.
Okay. Yeah. Well done.
Thank you, Rudolph. Thank you for that presentation. The next group, please. Optuna, Oluwabumi, and Fabian Wokeji. Are you ready?
Yeah, good afternoon.
All right, go ahead. Your time starts now.
So sorry, I can't present my screen. Okay. All right, so good afternoon, everyone. My name is Oluwabumi, and I'll be presenting on behalf of Team Optuna. Our project team is automobile manufacturing of electric cars. And the question we might first of all want to ask is why electric cars? This is majorly because electric cars have shown great promise in terms of helping to achieve sustainable transportation sector in the future, and in terms of its ability to be able to significantly help reduce the emission of greenhouse gases in the environment. The main project objective is to be able to help both, because our project is targeted at not just manufacturers but also consumers, to be able to help these ones to be able to draw insights about which cars have the highest efficiency, the fastest acceleration, and things like that, in order to help people know what to put into consideration during manufacturing, and see when trying to purchase electric vehicles, since the adoption is very fast and it is quite important. Some of the features we felt that we are not easily explanatory, or should I say we are not as intuitive, includes this. We have the powertrain, which explains where the engine of the vehicle sends power to, so as to make a vehicle move. We also have the range, which talks about the distance a car can travel. The efficiency, how well a vehicle converts its energy, that is the electrical energy or saved power, into the actual movement of the vehicle. And the plug type, which determines what kind of, how fast the vehicle will charge. Think of it as the way Android phones will have fast charging. Some of the insights we were able to draw. First of all, we were able to plot the distribution of the acceleration. And we see that there are very few outliers. Now, this distribution of acceleration shows the second with which if a car accelerates, because when you start a car, it doesn't accelerate at once. It takes time before it accelerates. And you can see just a few outlier, which is the Tesla brand. Now, it shows that the Tesla brand is very fast. If you look at the right here, you can also see that the Tesla brand cars are super fast with very, very high speed. And that is followed next by Porsche cars. So it might be something a manufacturer will want to consider when purchasing a car. Super nice cars. Then we consider the top speed and the prices. It is also super interesting to know that the Tesla cars, they are also the visible outliers in this distribution. They are super fast and quite expensive. Well, you can see you're getting the worth of your money. And then we have efficiency. We can see the distribution of the efficiency that is quite uniform. Well, not too uniform, but it's not as skewed as the other distribution plots which you've seen. And we can see that on the top of the list you have Mercedes. So these are the cars that you can be assured that with a fast charge they would actually go for longer, or the transform the electrical energy into the actual movement of your vehicle. So we have Audi on that list. You also have Tesla on that list. And we can see Tesla coming up and on the very top of most of this distribution, which we've shown here, which is a nice thing to see. And we also saw the distribution of rapid charge and with the price. Now we can see on the left here, we can see the plot which is here. We see that generally, although there aren't a lot of cars that are without rapid charge, but most of the cars with rapid charge would mostly cost less. Also, we also saw the distribution or how the powertrain of a vehicle would affect how fast it goes and how far it can go. We saw that all-wheel drives vehicles, they go faster and they go for longer. And generally, front-wheel drive tend to travel slower and they cover less distance, like other type of vehicles with other powertrain. And then we considered the numerical interdependence of some of these features. So it was interesting to know that acceleration differed inversely with the other features. And our correlation plot seemed to suggest that top speed and range did have a huge impact on the price of electric vehicles. Then we decided to try and see how other categorical features, how they relate with the price, and what insight a model could help us bring out from some of these features. Although it is an exploratory data analysis project, but we decided to try out the model and see what insight we could get. First of all, as our baseline, we tried out the linear regression method and we made a residual plot on the left. And we can see that this is the residual plot of trained samples. And we can see that most of the values of the error was close or equals to 0, which is quite commendable for the train. But if you look at the test here, you see really, really random predictions, which is not what we want, which is not good at all. And then we decided to try other models such as lasso and ridge regression. And finally, we came to a conclusion to use gradient boosting regression. Now we can see how beautiful this plot is. On the left-hand side, you see how well it does on the train sample. And you see a kind of linear correlation on the right sample. This is very good. I think we'd like to stick to this one. And then we decided to use that prediction to create model inferences and what features would even affect our price. Let's check. We see some car models.
Okay, thank you very much.
All right.
Okay, so the question I want to ask is, how did you compare, did you compare the models? You said you used 2, or did you try other models aside these 2?
Okay, so I mentioned that as our baseline, we use linear regression, but also we also tried lasso, ridge, and random forest models. But since it's an exploratory data analysis, we decided not to include it in our slide and do more from the plots we made.
Okay, thank you.
All right, thank you for that presentation. Seaborn, Akshay, and Raimi Aziz. Are you ready?
Yes, we're ready.
Please, can you share your screen?
Okay.
Prophet Group, please get ready. Have you started presenting? We can't hear you.
Okay, can you hear me now?
Yes. Please go ahead. Your time starts now.
All right, my name is Raimi Aziz, presenting for the Seaborn Group. We're talking about the Russian wholesale electricity market. So a little background about the electricity market in Russia. It's more like a trading system, more like a crypto trading, where you can buy and sell electricity for profit. Now the project objective is to tell us what the price is tomorrow, next week, or next year, and what the electricity consumption will be for same period of time. So a little background about the trading system again. This is a typical example where if a consumer, for example, now purchases say 100 megawatts of electricity that's for an hour, in the day ahead market purchases 100 megawatts. If by chance he uses maybe 90 or not up to 100 megawatts, he can sell the balance, that's whatever is left of the electricity on the balancing market to make profit. So that's just the idea of the trading system. All right, we're given three data sets. That's the intraday price, talking about the price within an hour, and then the day ahead prices. The intraday is for within a day. The day ahead is for day ahead. That is, you can buy ahead of a particular day. This is talking about gives us the details about the consumption and then the price of two regions, the European region and the Siberian region. And this is day ahead price, typical price for different regions in Russia. So for the purpose of this presentation, we'll be focusing on the day ahead price volume, which has the volume and the price. We did the analysis for the two data sets too, but because of the time constraints, and it's a whole lot of data to present within the time frame. So the data preprocessing, if we look at the prices, the price columns for the European and the Siberian region, there are a lot of zeros. Our research shows us that the zero represents when a consumer actually wants to buy at the current market price. Doesn't mean that there are zero values, it just means that the consumer is buying at the current market price. So what we did was we replaced the zero values with the main market price as at that particular time, which is what we did for the pre-processing. And then we went ahead to visualize the data. For the consumption in the European region, we can see a definite pattern which shows seasonality, and we can attribute this to summer and winter, where a lot of electricity is used towards the end of the year, maybe to heat up and other stuff. And then in the middle of the year, it goes down. Same goes for the consumption in Siberia. But for the price, there is no definite pattern, which is very typical of price data. There's no definite pattern. It doesn't mean that there's no pattern, actually. Anyway, in further slides, we'll see the trend and seasonality in the prices for these two regions. So the model we chose after considering other models, the model we chose, which has the best result, is the Prophet, the Facebook Prophet, and the steps include data preparation. We split the data, fit it, we did a forecast, and then we make future data frame. So this shows the consumption prediction for the European region. We can see the definite pattern from the beginning. And this is our test data is the last 30 dates of the data set. So this shows the prediction. The little trend here shows the prediction for the next 30. So this is the prediction table where we can see our actual value. Let's take 257 for example. The actual consumption value is 74,000, and our prediction goes 75,615. But we can see our lower limit and upper limits for the prediction as 72.8 and 78, which means that our prediction is still within the. Our actual value is still within our prediction value. So this is the seasonality. This shows the seasonality as described earlier in the visualization. It goes down in the middle of the year and then it comes back at the end of the year. And this is the trend in the consumption. We can see that it's actually going up at this particular period.
Please round up your time.
All right, this shows the prediction plot. Let me take this off. The blue line is our actual value, and the red line is the prediction. We can see that our prediction actually matches the actual value, and then we can see the lower limit, which is the green line. That's the lower limit of the prediction, and then the upper limit of the prediction. But then we can look at it in this shows data for 6 months. That's from April to September, and we can see our prediction. The red line. Okay, moving on. This is for the Siberia region, the consumption prediction for the Siberia region, as explained earlier. This is the prediction. And then
time up, please. Your time is on.
Well, for my conclusion, the consumption.
Hello, Aziz.
Yes, please. Okay, I'll stop.
Yeah, so sorry, your time is up. There are other groups presenting. Just hold on and take our questions. Very nice work done. Yeah, so my question is, I noticed some seasonality in your data sets. So I would like to know, how did you handle the seasonality during your modeling process, and why did you choose the traditional modeling process? That's the traditional model that's profits against other models like LSTM. Did you get my question?
Yes, I got your question. We actually tried other models first. We used the autoregressive model. The results came out good, but we noticed some form of there was overfitting at some points where we had almost 99% accuracy for some of the data, and for some we had as low as 2% accuracy, which means it doesn't exactly fit. And then before we decided to use the Prophet model.
Okay, how did you handle the seasonality during the modeling process?
Okay, for the seasonality, we actually included, I don't have my notebook here, but it was.
I can't hear you.
For the seasonality, can you hear me now?
Yeah, go ahead, please.
All right, for the seasonality, yeah, I don't have my notebook on screen. I would have showed the model code. It was included during the prediction to automatic detection of seasonality.
Okay, that's all from my end. It's okay, thank you.
All right, thank you. The next group.
All right.
The next group, Prophets group, Amit and Kunle, please go ahead.
Good afternoon, ladies and gentlemen. My name is Adewale Adekunle, and I am representative of the Prophet Group. And soon you will find out why we are called the Prophet Group. We are here to take you on automobile manufacturing. Our focus will be on electric vehicles. Here are my fellow group members and the roles they played in the development cycle of our machine learning algorithm. The world has decided to adopt clean energy because of the environmental impact of fossil fuel engines. We have impacts like global warming, increased CO2 emissions. Thus, the demand for electric vehicles is set to increase with time. And as companies improve upon the performance of their vehicle, my team has come up with a way for you to predict how much it would cost you to get an electric vehicle based on the features you want. Here is our process flow of the model development. My colleague Amit will take you in details of the process flow of our algorithm.
Thanks, Kunle. Hello, everybody. This is Amit here. So as you know, every ML project will have certain stages. So let me briefly take you through each stage. First of all comes the data collection. So we use the EV database website to collect the data. The technology used was Selenium, from where we got 181 unique records, along with several features such as acceleration, fast charge efficiency, and many more. So as you know, in this world, you never get a clean data. We did a lot of cleaning on the data, and after that, we got some insights. Let me share those insights with you. The insights were like, as you see, some of the brands focused on the efficiency. If you see Toyota, Citroen, Byton, those are the brands which focus more on the efficiency of the vehicle. Whereas some of the brands focused on the top speed on the models that they provided in the market. Now, who doesn't know Tesla? We all know Tesla. So the brands like Tesla, Porsche, Lucid, they provided the most models with the top speed in the market. Further, as you know, these are not everything. Many customers are also looking for variety. So the brands like Audi, Tesla, Volkswagen, they provided the variety of models in the market. Like Audi gave as many as 15 models in the same market. Closely followed was Tesla with 13 models and Volkswagen with 12 models in the same market. So these are the, so we come to know that different brands are focusing on different features to attract the customers to buy the EV vehicles. Now, one another thing which we observed is the range of the cars and the battery capacity was highly related, and you can see the R-squared value of 0.79. So this feature played an important role as we go ahead in our machine learning. Let me take you through that further. Now, if you see, these are the features that we finally narrowed down to use in our model. Now, you must be thinking, from many features, how did we narrow down to a few features? So I will tell you what we did. We did 5 rounds of experimentations and iterations. So we were faced with many questions like what to do with the null values. Shall we drop them? Shall we replace them with the median value? Or shall we use the column values in the adjoining columns to calculate those? And like we had also brand names. What to do with the brand names? How to encode them using ordinal numbers or one-hot encoding, or use the get dummies method. So what we did was, in each iteration, we tried out different things. And for each iteration, we used 3 models: linear regression, random forest, and XGBoost. And the one particular metric that we used was R2 score. So finally, changing each value in different iteration. In the 5th iteration, we got a high score, R2 high score of 0.82 in the linear regression. So we finalized this one. These features we finalized for our linear regression model. Now, after this comes the deployment. So now over again back to my colleague Kunle.
All right, enough of the theoretical aspects. Let's predict the price of your electric vehicle based on the features you want. If you click on the URL on the screen, it's take you to our deployed model, which was deployed on Heroku. We developed it using Flask. Let's predict now. Let's say vehicle name, we pick the Tesla. Then the battery, I want 180 kilowatts. Then the acceleration, 3.2 seconds. Top speed, 220. Let's drive fast. 220. 400. I want distance 400 kilometers. Then the efficiency, 170. Then fast charge, let's go 1000. Now, if you click on the predict price, it will show you the price, how much it will cost you to get this kind of vehicle with these specifications. While the magic in the background is happening, the price was converted into USD because it is our universal standard, and it's easy for us to understand how it correlates to the vehicle. So as we all know, Tesla is actually the biggest brand in the market. So that's why I picked it, because who else wants to own a Tesla? It will cost you $73,385 to get your Tesla vehicle with those specifications you need.
All right.
Okay. One of the challenges we encountered was that we do not have enough. All right. One challenge we encountered was that we don't have enough unique vehicles to accurately predict the price for your electric vehicle, and also the time constraint to try out different scenarios was also there. We have successfully completed our deployed model, and as time goes by, more vehicles will be developed, and we will have data to train our model to accurately predict the price of the vehicle. Thank you very much for listening to us. Now, if you have a question or doubt, we would like to answer them.
Thank you very much for that presentation. Over to you, judges.
Very well done. I appreciate this. Just one question. So in the feature engineering, you mentioned like dropping off number of seats like was not that much relevant. Like number of seats was not relevant in price. Do you think like in real world this works out? Because if we increase the number of seats in car, obviously the price will increase.
Right. Yeah. So your question is very very relevant. What we did is we also thought the same thing. But when we saw in the real world, generally the luxury cars or the high-end cars will mostly tend to have 2 seats, and you will also know that they will tend to be very highly priced. So that way you don't see the linear relationship there. The car will be highly priced, but the number of seats will be low. And during our iterations of experiments also, we kept that in the all of the iterations, but we didn't see much difference it bringing on to the price. Hence, in the last iteration we dropped it, whereas in other iterations we had kept it.
So basically, you are saying like your model is more inclined towards luxury cars.
No, I wouldn't say only inclined for luxury cars. I am saying that we tried it. We tried that feature in various iterations, but it didn't seem to have that much effect on the final score. That's why we dropped it. Yeah.
Okay then. Yeah. Well done. Thanks.
Thank you.
Thank you. The next group, please. Dilip, Gaius, Asor, Chimeni. Please go ahead with the presentation. Your time starts now.
Okay. Good afternoon.
Good afternoon.
Can you see my screen?
Yes, please go ahead.
Okay, so I'm Gaius Chimeni from Group Dealing, and our project is about credit card approval prediction. So these are the group members that contributed to the project. Credit card approval and evaluation process. It refers to the process that lending companies use to scrutinize their applicants for credits and loans. So it entails collecting information from the solution our project is going to apply to a predictive model if either an approval or rejection status of the application. So the workflow of the project, we began by understanding the project, processed our data for our machine learning model, did the split into test and train. Then we fitted the data set to a logistic regression model, checked our metrics, then we tried to improve the model, and then we selected the best model. So the workflow, these were the features used for prediction. Initially, all the features of the data set. Then we carried out analysis.
We can't hear you.
Can you hear me?
It's faint, so sis.
Can you hear me now?
Yes, your time is still going, so.
Okay, so we carried out univariate analysis comparing one variable to the then we'll notice that for the prior defaults column, it had a high correlation with the target variable. You see that those that had prior defaults were not given the loans, they were rejected, and those that had actually given more. And also, we checked the gender to see if gender had anything to do with it. We checked for outliers and saw some columns had outliers in them, and then we dealt with them appropriately. So for our modeling, we checked the correlation between the features and the target variable and also against the features themselves. Use that to estimate features that had correlations. Using our logistic regression, we had to convert the columns that were object type to numerical type using the label encoder. And then after checking the correlation plot and everything, we came up with selected the best 6 features, highest correlation, and also using the domain knowledge to select the ones that tried 3 models. We first used the logistic regression model, whereby we used all the features. Then we saw that we needed a higher accuracy at that point. Then we tried grid search to optimize the parameter. We noticed any significant change before we applied so that the accuracy was still the same. So after further research, we realized the accuracy was not going to be the best metric for this. So precision will actually be better because precision will let us know that, okay, the people who are actually approving the credit for or rejecting them for, we are giving a 91% assurance that we are right, that either they will be defaulters or they will not be defaulters. So we deployed the model on using Streamlit. Shot of the model. So I'll quickly can you see my screen?
Yes, we can see your screen, but we are struggling to hear you.
Okay, I'm sorry. Okay, can you?
Yes.
Streamlit application. So you put in your applicant's details before you click the predict button to make sure that all you've inputted is what you want to input. Either get request is
all right, your time is up. Over to the judges, please.
Okay, so next presentation, I have just one question. So during your model deployment, right, is there a place to include the confidence of your predictions? Because credit card approval is actually a very serious issue. So you can't just say, okay, approve this, but like the approval rate is like, the confidence is like very low. So are you considering that, or is it part of your UI?
No, the confidence level is not actually shown yet, but in subsequent modifications we'll add it.
It's one God that told me that I'm not entered, I'm carrying Jesus. You understand?
Salihat.
Yes, that's also my.
Yes. All right, thank you. Thank you very much for that presentation. The next group, please. Matplotlib, Sanyok Jane and Sandy, please go ahead.
Good afternoon, everyone. My name is Sandy Omniabos, and I and Sanyok Jane will be presenting on behalf of the Matplot library team. The title of our project was Movie Recommendations Using ML. The aim of this project was to build an algorithm that predicts movies based on user ratings to an accuracy of 10%. Next slide, please. Next slide. Hello, next slide. We sourced our data set from Kaggle, and the criteria for choosing this data set was that it should have a user rating column and it should be up to date. The chosen data set was Netflix TV shows and movie by Shivam Bassam. We carried out a statistical summary on our data set, and we've cleaned the data set by filling missing cast and director roles with unknown and unspecified respectively. We dropped every other missing role that wasn't necessary for our data set in order to improve the accuracy of our model. Next slide. The visualization carried out, from the visualizations carried out on our data set, we found that TVMA, which is TV for mature audience, was the rating with the highest count, of which movies formed the larger proportion. We also found that the United States, India, and United Kingdom were the countries with the highest amount of shows and movies on Netflix. My colleague will take on from here.
Thank you. So now we come to the actual machine learning part. So for the feature engineering, we decided to use NLP to create a machine learning model which can provide movie recommendations based on the plot of the movie. Whenever a user watches a movie, the user would like to watch other movies which are similar to the movie which he has currently watched. So first, since our data set consisted of two parts, it consisted all movies and TV shows. We first removed all listings of TV shows and we created a TF IDF vectorizer, which stands for term frequency inverse document frequency, which creates a inverse document frequency of the plot of all movies. And before doing that, we also removed all the stop words. Stop words are the words which are used commonly, such as the, and, etc. And for model training and evaluation, we created a linear kernel using the scikit-learn library. And the linear kernel calculated the cosine similarity of each plot of the movie in the dataset from the TF-IDF vectorizer. So once the cosine similarities are calculated, we can simply enter a movie name. The movie name is looked up from the dataset, and the movies which are close to it are recommended to the user. So this is how cosine similarity works. This is a similar example. So here you can see there are the cosine similarity plot of 4 words, and you can see they have got various angles. So the target word here is sacred, and the cosine similarity score between sacred and shrine is 0.58, whereas between sacred and holy is 0.73. So this is how a model works. We will now show a live demo of the model. So this is our model deployed on Heroku using Streamlit. And so once we load the page, it will ask us to enter a movie here. So I will enter a title, such as, for example, Indiana Jones and the Raiders of the Lost Ark. And when I click on search, it will take a few seconds. And afterwards, you can see that it recommends me 10 similar movies. And so as expected, the first 3 movies are other parts of Indiana Jones. And then there are also a few more movies with similar plots. So this was a model deployment production process. Thank you.
Thank you for that presentation.
Yeah, are you done?
Hello, sir.
Okay,
yes, sir.
my question, please. Oh, nice work done. So I just want to ask, my question is coming from maybe like a user perspective. As a user making use of your system, how do I plug in a movie? I'm sure like the movies enlisted there are like the movies you use for your training. So as a user, how do I plug in the movie, and how does the data set get to like how does the system get to make predictions for me?
So you mean entering a movie, your own custom movie name?
Yeah, exactly. How does it make prediction for me?
So we apologize, but our data set, it currently it's right now it's only limited to the movies in our data set.
Sorry. With your problem statements, you started like the business problem. Like,
Uka, please, can you mute yourself?
Can you hear me?
Yes, I can hear you. So.
Yeah, the business problem now, like the problem you're trying to solve. With your solution, do you think like you are able to solve the?
Yes, so we will be able to solve this problem. We can scrape. So, for example, if you enter a movie name such as Jurassic Park, which is not in the data set, we can scrape something like the IMDb rating or IMDb page or the Wikipedia page. And using that, the cosine similarity will again be calculated in real time, and the closest one will be shown to you.
Okay, that's fine. Nice work.
Thank you, sir.
All right, thank you. Thank you for that presentation. The next group, please. Saipi, Chinonso Agwonye and Aino Bolahon. Are you ready? Scrapey, please get ready. And please let me remind you, you're not presenting, please mute yourself. Thank you. Okay, please go ahead with your presentation, Chinonso.
Okay, can you see my screen?
No.
What about now?
Okay, it's coming up. All right, you can see your screen now. Go ahead.
Okay, good afternoon, everyone. I'm Chioso from TrackPy Group. I and my colleague Bola will be presenting our work on educational ranking projects. And these are the members of the group. This problem statement basically is about solving issues on educational sector. As we all know, there is a great competition in the educational sector where students and parents are looking to enroll their students, their awards in the best institution. Even countries and institutions are trying to attract the best students and the brightest mind to their camp. The Times Higher Education, which we are ranking sheet we are using, are doing a great job, but we also notice they limited their data ranking to the top 1,000%. So we try to sort out this, solve this issue. So aside from carrying out exploratory data analysis on the data set we have, we also use what we have learned and also make research to be able to build a model so that we can help students provide trusted information about academic institutions in terms of ranking. We are also looking to help institutions predict their rank in future in terms of allowing them to see, okay, if they can improve so and so features in coming years, their ranking will increase. And this is the process we went through from extraction, cleaning to model deployment, and also slide preparation. In our correlation heat map, when we are looking through the data set, we notice a good correlation between teaching and citation. And citation is under research also. So we also understand from there, we could also look into and say, for schools that want to be on the top, the teaching citation and the research rating needs to go high for them to move up the ranking. And we'll put that in some of our exploratory data analysis. Here we're looking at the top institutions with the top numbers of institutions, countries with top number of institutions. From here, we can see that the United States has one of the top, the greatest number of institutions on the ranking sheet. We are working with data from 2015 to 2021, and that shows a performing part for the country. And now why we say that is because in the overall progress, when you have more institutions that are ranking as top, it reduces the educational pressure in some particular set of schools. So what means that a lot of students have options on institutions they need to go to when it comes to top world ranking institution, not just having one top institution, and all students are trying to put their pressure on that place. We also notice that Egypt is the only African country that meets the top 20 countries, which is very poor, and we need to do better in Africa for less ranking. Then here we also look at, I talk about how citation and teaching improve the ranking of schools. We try to compare the citation at the schools with top rankings on citation and teaching. And if you look at these institutions from also down to University of Chicago, they came top in terms of ranking. And if you look at the world ranking data set we are working with, which because of time we will not probably show that, you will see them coming top among these years. Then this is also a key part of our exploratory data analysis, where we look into the student per staff data. As you all know, student per staff data is a very key feature for learning purpose. And here we can see that the growth of students for each year per staff is going very high, which is implicatory. And what I mean by implicatory is that as more students are coming into the university, institution needs to also look into building on their facilities. They need to work on their facilities, also improve on by trying to also increase the academic staff so that we don't have more students overwhelming the current academic staff. And how can they do that? Either by retaining more graduating students or also expanding the core facilities. This is to avoid pressure in the future so that as these students per staff ratio go, we don't overpressure the institution, the staff, academic staff with workloads, and also the students are still getting the best from the facility. That is what we saw there. Now, my colleague Bola will talk about our modeling process and what's the other last part of our training, of our exploratory process.
Okay. For our model, we tested 3 models and found the support vector regression to be the most useful for our ranking problem. As you can see, we can take from this, what we can take from this is that the first diagram scatter plot shows the correlation between our prediction and our test data set before parameter tuning. What we can take from this is that the data sets are far from the line of best fit before the parameter tuning, while our east plot shows the difference between our data and the predicted values. For this, we can see that we have more distribution far from 0. However, after the upper parameter tuning, in the second set of diagrams, we can see that more of the data falls along the line of best fit, and
You have
our
30
distributions
seconds.
for the difference are closer to 0. We have deployed our model using Streamlit, which takes the data and outputs the rank for any given university. All you need to do is input the data you have, and you get the prediction. As you can see below, here we have the school ranking of 420 with our test data sets in this instance. Thank you.
All right, thank you. Over to our judges.
I have 2 questions for you. Firstly, what is that thing you are trying to predict? And
Okay, so firstly, what we are trying to predict is the rank of the university the applicant might want to apply for. So for example, he wants to go to Cambridge University. We're trying to predict or try to give him information on how well that university does in relationship with other universities.
Okay, and secondly, if there is a university which is not in your database, will it be able to handle that?
Yes, it would. It does have to be in our database. Yes.
Okay, thanks.
Thank you. Thank you for that presentation. The next group, Scrapey. God bless James. Please go ahead with your presentation. God bless James and Happy Okodua. Are you ready?
Yeah, we're ready. So I'm sharing my screen.
All right, you have 5 minutes. Time starts now.
So hello, good afternoon, everyone. I'm God bless James of Team Scrapey, and with the help of my teammate, Happy Okodua, who will walk you through our project on hotel recommendations. So briefly, our hotel recommender system is a software that provides suggestion of hotels to users based on user preference data. So you might want to ask, why such a system? So I think such a system is good to have because users often lack the personal experience or competence to evaluate the potentially overwhelming amount of hotel data on websites. So with that said, going forward, I'm going to talk about the Scrapey team, the data set we used, and then also walk you through the implementation and deployment phase of the project. So the Scrapey team consists of 3 sub-teams based on the project's subtasks. So we have the data collection team, the data exploration team, and then the deployment and implementation team. So with that said, we use a data set consisting of 12,372 customer review records of 868 unique hotels located across 31 states in Nigeria. So how did we get our data? We actually wrote a custom Scrapey spider to crawl the hotels.ng website to get this data. And as you can see on the screen, you can see the features we were able to scrape. So after that, we did some basic exploratory data analysis and pre-processing, and then we derived some very beautiful insights. So over to Happy to share some of these insights with you.
Thank you, God bless. Of the 31 states in our data set, Lagos ranks highest as the state with the highest number of hotels, with 366 hotels, while states like Benue, Kogi, and Katsina have 1 hotel each. Moving ahead, the most expensive hotel in Nigeria is Lagos Oriental Hotel, with an average price of 250,000 naira, followed closely by the Whitbika Hotel, and the rest of them, as you can see on the screen. Now, by user ratings, Ekpe Resort comes top as the hotel which is rated very high by users, having an average rating of 10. So an important point to note is that over the years, some hotels have gathered a lot of reviews from users. And from these hotels, Benny Gold Hotels has the highest review with a review of 350. On to the next chart. 2017 is the year with the highest number of reviews, having a total review of 3,500, while 2021, the year we are currently in, has a total review of about 300. God bless, over to you.
Yeah, thank you, Ms. Happy. So during the research phase of our project, we were able to discover that there are different or various approaches to building a recommender system, including collaborative filtering, the content-based approach, and then the knowledge-based approach. There's also the hybrid approach. But considering our data set and considering the fact that an item like an hotel usually lacks rating, And then the user preference data changes over time. So we wanted to work with the review feature in our data set. But to do that, a user will likely describe a perfect hotel, like this hotel is beautiful. I want this hotel in a serene environment. So what we wanted to do was to get the sentiment of the reviews. So we wrote a sentiment analyzer function and ran it on the reviews column. And then as you can see on the screen, we have the positive review feature. So after deploying this model, we saw that the performance wasn't up to what we wanted. So we needed more keywords in our data set. So we decided to concatenate the positive reviews as well as the description of the hotels. And then we got a new feature called the hotel summary. So immediately I'm going to walk you through the process of the recommendation. So firstly, a user is expected to input their perfect description of the hotel they want to visit. And after that, some basic natural language processing tasks are carried out using the preprocessed function we wrote. So basically it removes the stop words, lemmatizes the tokens, and then remove out of vocabulary words. And then after this is done, it extracts keywords. A keyword can be a background like good environment, good customer service, etc. So after that, this is converted to a word vector. This is because we want to calculate the similarity score between the preprocessed hotel data and then the user description. So for this, we utilize a pre-trained model provided by Spacey, the Encore Web MD, which contains about 20,000 unique vectors. So after that, we decided to implement the cosine similarity algorithm for checking the similarity between the hotel description provided by the user and then the hotel summary in our dataset. And then these similarity scores are stored. And after storing them, they are sorted. And then the top hotels based on similarity score is recommended to the user. So I'm going to show you a demo of the project because we actually deployed it on using Streamlit so that users can visit the site and so users can visit the site so that we can really evaluate the site, since this is not a typical supervised learning problem. So the first thing the user has to do is simply impute the state they want to visit. So once they impute the state, the algorithm clusters the hotels based on the state, and then they enter the description, and then they click the press me button. So the algorithm calls the recommend function, and you see the top hotels are recommended. And then the confidence of our model is simply the similarity score provided by the system. Thank you.
Thank you for that presentation. Over to the judges, please. Salihat, are you there?
Okay, so I'd like to take that. So just one question. How would you take like price and other quantitative factors in consideration of the model?
Yeah, so basically the price data we got from the website wasn't too accurate. There were a lot of missing values. So we felt that the price wasn't too useful for prediction. So basically users go, and sometimes this price factor is specified in words because a user might specify that they want a budget hotel, an expensive hotel, or a luxurious hotel. And all these things are included in the summary, the hotel summary feature in our data set. So it's all encompassing.
Please take note that like it's not for everyone. Let's say a 5-star hotel may cost more, but there is like the price may be also a factor for considerations.
Thank you.
That's from my side. Thanks.
All right, thank you for that presentation. The next group, please. Apache Group, Orina Tolulope and Lawani Kingsley. Please go ahead with your presentation.
Good day, Hamoye. Hello, can you hear me?
We can hear you, please go ahead.
Presenting for Apache. So here comes the burning questions. Everybody wants to make money. And
please, can you increase your volume?
Can you hear me now?
Yes, better. Go ahead.
Okay, I said here comes the burning question. So everybody wants to make money. and we're in search of what to invest in. So Bitcoin could be the way out, but most likely it's because of the high volatility in price and the fact that it's extremely risky. So people might not consider that. But what if we could build a model that could predict the next bit, the next crypto, and of course observe the future price? So that's the tone of our project. So the aim of our project is to, sorry, next slide, is to predict the next big cryptocurrency that will offer high returns, also stability in price, and also potential growth over the years. So now, how do we go about solving this? So what we'll do first is to go on the internet and with the intention of gathering historical data for 1,000 to gather cryptocurrency for 1,002 cryptocurrency. So, but of course, because of time constraint, we were only able to gather 49 data set because of the fact that 1,002 is quite based on the time it's pulled. So we just work on that. And from that, we actually performed them, of course, from Yahoo Finance. Basically, we look at some major authoritative sites, CoinMart, CoinGecko, and Yahoo Finance. So from Yahoo Finance, we scraped cryptocurrencies, 49 cryptocurrencies, and also Ethereum data set. So we did EDA on our data sets. That's the 49 now. Of course, these are the features that we worked on. So we intend on using the market cap, but it's a little bit biased. So we just work with this and just drop that. So now, based on our EDA that we did on the 10 cryptos, so we find out that 49, then we narrow it down to 10. Then from this 10, we found out that there's one interesting point that shows a lot of promising. So from our charts, of course, Bitcoin top the chart, but I'm looking at Bitcoin. So we saw another coin, which is Ethereum, and over the years, that has been stable, a bit around. So that took our interest. So we decided to just look into Ethereum and desire to forecast the present price. So over to you, Tolu Orina.
Okay. Thank you very much. Good day, everyone. So I'll be continuing from where my colleague stopped. So basically, please, can you stop sharing your screen, Lawan?
Okay.
Okay, so can you see my screen? Okay, so like you said, the next big thing that we are looking to predict in this particular project is Ethereum, and that's because we are using the basis of market capitalization, and market capitalization to be the total value of all coins that have been mined when we're talking about cryptocurrencies. And it's calculated by multiplying the number of coins in circulation by the current market price. And it is often the most important indicator when we are ranking cryptocurrencies. So continuing from this is the candlestick plot of Ethereum, and it shows an uptrend in the price of Ethereum generally. So these are the features we used for our models. We use the volume, the daily return, the direction, MA10, MA50, that's the moving averages for that particular time period. And these are the exogenous data in particular, while the endogenous data was the close price, which is what we always look to predict whenever we want to forecast in the stock market. So the two algorithms that we use. Hello, please, can you hear me?
Go ahead, yes, we can hear you.
All right. So the linear regression model and the ARIMA model, out of these two, the ARIMA model was the best. And okay. So these are the predictions from the ARIMA model. We carried out in-sample prediction, and we also carried an out of the sample forecast for this model with this range of confidence interval being highlighted there. So from our ARIMA model, we had a mean absolute error of 73.74. And these are the results using the Stat Models API, the ARIMA SARIMAX API.
and we can see a very good significance with the p-value very close to 0 for most of our variables. And in conclusion, this project helps us to show that we can predict and decipher cryptocurrency prices by using various features that we get from technical analysis. And even if we are able to continue with this project, we'll be able to use fundamental analysis depending on the type of trader that is going to work on it. As there are different types of traders, there are day traders, there are scalp traders, there are long-term traders, which are investors in particular. So our future work and recommendations include deployment of our model, as we didn't have enough time to deploy the model. And so that will be all for now. Thank you very much.
All right, thank you.
Thank you, Tolulope. Sorry, I want to know, like, what do you mean by use bleeding edge ML techniques like LSTM and Prophet? Sorry, can you explain what that means?
Okay, what we mean by using bleeding ML techniques is we're only able to use ARIMA model and the linear regression model because of the time constraints. So we are sure that we can improve our predictions by using these techniques, deep learning with LSTM and Prophet in particular.
Yeah, so talking about ARIMA model, like, was there, did you notice any seasonality as to how people buy or use cryptocurrency during your analysis?
There wasn't any seasonality in particular. There wasn't any seasonality noticed.
Okay, fine. So what metrics did you use? I saw the mean absolute error, and then I pretty much know that I mean that is basically used for ARIMA, and then there is something called the AIC and BIC value that is like very much considered. Did you consider that at all during your evaluation?
Yes, we did.
Can you talk a bit about it, please?
Okay, the AIC and the BIC. The AIC is the AKK information criterion, and it's generally good when we want to predict when we want to make predictions on using the ARIMA model. So we take the lowest, the P and the Q values with the lowest AIC and the BIC. So we run our predictions through a loop first to get that particular P and Q. So the P we got was 0 for the autoregressive constant, and for the moving average, we had 1. So we can see it in this particular diagram. In this model, 0 and 1 there. Then a co-integration of 1, which is the difference value, to remove the trend.
Okay.
Make it stationary.
Okay, that's nice. Another quick one, please. You made mention of illegal activities, exchange rates, volatility, and vulnerabilities of the infrastructures underlying like cryptocurrency. Can you like explain a bit more about that? Like, it seems like something I'm very much interested in.
Okay. Basically, volatility is usually a variance of the expected price that we want to derive. So the cryptocurrency is basically a very high volatility market, and we all know this, but we got to find out there are some cryptos that we can also test our predictions on that have lower volatility. And these include this particular visualization here, this Elrond and Cosmos. So we can always try this whenever we want to use a low volatility index.
Okay, that's fine. Thank you.
Yes, thank you very much.
All right, thank you. The next group, please. Numpai, Nkechi, and Eniola. Please go ahead with your presentation.
Can everyone see my screen?
Yes.
I'm sorry, Nkechi.
Nkechi, please unmute yourself so we can hear you.
Sorry about that. I was trying to listen. Good day, everyone. My name is Nkechi Ezipwe. Today, I and my colleague Eniola Fagbenyiro will be presenting this project titled Entrepreneurship Startup on behalf of our team, Team Dompai. Moving on, Eniola. Our outline runs from introduction down to conclusion. The startup world is flourishing. Venture capitalists are investing in excess of hundreds of billions each year on the hope that a startup will succeed. The aim of this project is to mitigate the associated risk by creating a model that predicts to a very high extent which startups are likely to be acquired. Our data was sourced from Kaggle and can be accessed through this link. These are the tools and modules that we used. We called some, and these are our team members who also worked on the project. We called some functions to clean the data set and prepare it for analysis. The data size, we had 923 rows and 49 columns. Domain knowledge of the state codes and zip codes and a plot of the longitude and latitude data places the location of this data set in the United States. A plot of the successful to failed startups shows that our data set is balanced. Moving on, US startups are concentrated in California, closely followed by New York, then Massachusetts. When we plotted the startups versus their category, we noticed that the categories with the highest numbers of startups are software, web, model, enterprise. Moving on, this plot shows a very interesting insight. It shows that startups prior to the year 2000 all failed, and the 21st century came with a boom of startups. There was a steady decline from the year 2010, which had a high ratio of failed startups to successful startups. Moving on, all startups with a form of investment, either angel investment or venture capitalist investment, are more likely to succeed than fail. Also, we also noticed from this plot that startups with higher funding amounts are more likely to succeed, as we can see from this trend. Plotting the first milestone year, the first year of funding, last milestone year, and last year of funding, we noticed that the first 5 years are very critical to a startup's existence. This was also consolidated with this plot where we plotted the age in which most startups close. And we noticed that the first 5 years had the highest number of startups closure. There was a steady decline after that, making the first 5 years very critical. Also, we noticed that the higher the number of funding rounds that a startup undergoes, the less likely it is to fail, as you can see from the trend. The percentage of successful startups was plotted using this pie chart, and we can see that the web, software, enterprise, and advertising startups had the highest numbers of successful startups. Finally, we created a heat map to show feature correlation, which was very important in delineating which features had high correlation to avoid multicollinearity on our model.
As shown in the previous heat map, some features had high correlation and we dropped some of them. After that, we scaled the data using min-max scaler, and then we used select k-best and f-classic to select the features that were most important. We were able to select 20 of these features, and then we tested different models. We tested logistic regression, decision tree classifier, random forest, and some others. We compared their accuracy score, F1 score, and precision. And after doing this, we were able to select the decision tree classifier with a max depth of 4. It gave us an accuracy of 80.9, an F1 score of 0.87, and precision of 0.81. For potential investors that would like to see if a startup could fail or succeed, we created this web page so they can input the values of a startup they're interested in and find out if that startup is going to succeed or fail. So I'm just going to input some values and test if this our hypothetical startup is going to succeed or if it is going to fail. So waiting for the model to predict. the status of this startup, we can see that this particular startup is going to succeed. In conclusion, the first 5 years of a startup are very important, and that is when most startups are likely to get acquired or get funding. Thank you very much for listening.
Thank you. Thank you. Over to the judges.
Okay, so a nice one. I just want to like to ask you. The data set, I can see it's very old. These 2 years have been a really great boom for startups, and I think you should really try to get the data for that. That's just one question. In the slides, you mentioned like startups before 2000 were not successful, but I guess Google was founded back then. Can you please justify this?
In the data sets we got, I'm not sure, Google was not part of it. So we don't have Google in that particular data set. And all the startups before the year 2000 actually failed according to our data set.
Okay. So I guess your data set was lacking. No worries, else good work. Thanks.
Thank you.
All right, thank you very much. The next group, Cat Boost, Abdul Karim Usman and Eswa Gaglo. Please pardon me if I didn't pronounce your name correct. Please go ahead with your presentation. We can't hear you.
Okay. Can you hear me now?
Yes.
All right now. Good afternoon, everyone. I'm Usman, and I'm presenting for Cat Boost Group, and we are basically going to be presenting on exploratory data analysis and data visualization on airline crashes. We are not deploying the model. We are not just working on how to visualize the data. And the team leads, we have the assistants, and the code analyst. The data set we use for the project were resourced from the Kaggle, the aviation, the accident data synopsis, and GitHub for other data sets like regional code, countries, continent, and World Bank for airline passengers and population. The outline of the project is we have the analytical goals, the setup of the environment, the data analysis, exploratory data analysis, data preparation, feature engineering, and visualizations and inference. Okay. Yeah, the goal is to the goal is to extract and clean the data. We are going to manipulate some data sets to obtain useful information, conduct exploratory data analysis, and also the client asks some questions to ask, like how many planes crash early, how many people are on board, survivors, and others. Information on number of crashes by type of aircraft, phase of flight, and reason for abort. While setting the environment, we import libraries like Panda, Seaborn for the visualization, because this is a visualization project. Uh, we use Plotly, NumPy, Seaborn, Matplotlib, and others for the visualizations, and we load these assets from GitHub and from Kaggle dataset we got. Out from expert data analysis, we saw that we have 31 columns of data, and we have a small amount of numerical values, while we have a large amount of categorical values. Okay. Yeah. While preparing data for the visualizations, we saw that we have over 60%. We drop attributes with percent missing greater than 60 percentage, and the one with high unique values. And for numerical columns, they have null values. We put zero imputation, while that of categorical column, either we put unknown or use mode imputations. And other ones what we did is that for a particular attribute where we have a lot of features, a lot of value counts, we have just with the one with less than 100, we take it to the others and we combine the data sets as well. What of the feature engineering we did is also we engineered the event date into year, the month, the days, and week number, and we combine the total injured in the data set and total uninjured to get the total number of passengers on board. Another thing we get tests for word cloud from the make attributes. All right. From visualizations, we saw that the total frequency of accident from the data set, we saw that the accident from data set we got from the cargo, we saw that the accident started from 1980, and we see that there is a decline in the frequency of accident over the years. Maybe the reason why we just said that this might happen because of the fact that there's improvement in technologies, infrastructures, airline constructions, and so on and so forth. While from the data set, we saw that the total frequency of passengers on board is not it's not good, and it's not showing a better stuff because we are seeing high and low. Then we sort for airline passengers on World Bank database. Then we see the plot on the red on the left showing the red or showing the total frequency of airline passengers by year, and that was from the World Bank to validate it based on our data set. We see that getting the data from the World Bank give us opportunity to know that to show the progressive frequency of passengers by year relative to what our data set is giving us. From the data set, we got that the cost of amount of accident by month. We saw that the month July the highest number of frequency of accident, while that of Saturday, the day Saturday has the highest count of accident. And from the by grouping the accident by continent, you see that North America has the highest, while Oceania has the lowest of the count. Okay, from the frequency of accident by the what are the purpose is the purpose of passenger. What is the purpose of flight? We saw that the personal reasons as the highest, why by the instructions and also other area applications as of the highest, and also the phase of flight. When is this occurring? We see that we have the landing as the highest and the takeoff and followed by the cruise. Then we use a dashboard to suggest which the population to find out how much people are going out traveling by air, what is the locations and the population and the total passengers. And we use the text, the word cloud text is since we are doing not data visualizations, not modeling. We just use the text to see, okay, this for the makers. We see that Cessna and the Piper, they are the highest that causes the highest makers that have a frequent number of accidents. And from the globe, we see that the United States has the highest number of frequency of accidents because of the data set we had from the cargo. Now, the visualizations, we see that this is done on plot. We cannot see it as much like this. Or if let me see if I can post. This shows the frequency of airline accident in the United States, and while the other one shows the that of airline from 1970 to 2020, based on the using the mode map. Yeah, what we infer from this is that it seems that 1970 to 1990s were not the best year in the history of airline. We got more in details by checking the Wikipedia aviation safety to see that the reason why these 1970s this year were not the best, and also we see that most of accidents happen during the landing and takeoffs, and we propose a lot of training and orientation should be given to the pilots and operators from the OSHA, Occupational Safety and Hazard Administrators. And it was shown that a lot of passengers were boarded on Cessna and Piper aircraft, and they had a higher number of fatalities. Also,
All
the
right,
project. Yes,
Usman,
yes,
sorry,
sir.
you've extended your time. Sorry.
All right, sir.
Yeah, thank you for the presentation. And
All right.
I think there is a group that works on something similar to this.
All
And
right.
there was a question I asked them. So you during your data visualization on slide 10, you showed the total frequency of accidents by year. So I would like to know, what do you think was the reason for that spike in number of accidents in the 1980s? If you go to slide 10.
Sorry, this one.
Yeah, yes, like
What?
it was from 1950 to like the late 1970s. Everything was like on a very streamline on deviated.
The data, sorry, sir. The data set given by during that year, it was not the data was set slightly from 1980. The other ones I should have done is to remove the data set the 1960 to 1970 because it was somehow minimal. The data set started from 1980. Just the what I can say is that at that point, I think maybe the instrument, that's why I said that the technologies are the things, maybe the improvement in technologies and using the AI and improvement in technologies comes in, accidents and the this thing drops. That's one of the reasons that one of the things we could gather from it, sir.
You mean you didn't have any data from 1950 to the late 1970s?
From the where we get our data on cargo. This is what we get. Like this is the data of the 1980, and we couldn't get the other ones. You get, sir?
Okay, is this an analysis problem or a machine learning prediction problem?
Analysis problem.
So with your analysis now, what do you recommend? Like, what's your recommendation?
Yeah, we recommend that for the for the makers also, like is that what I said, that the because we see that much of these accidents across during landing and taking off, and that the pilots also, there should be encouragement, and there shall be training, proper training, and orientations for them, and also as much as possible, pilots, let me say pilots and people who are also passengers who are going for different course for the airline, they should just reduce the amount of different amount of they're traveling. By in essence, that if you are going for goods and services, you can get some companies, logistics companies, that can help you. That have not you going and everybody going for this kind of course. If you are going for goods and services, you can get logistic people to help you get it, so that it will decrease the number of accidents. I think what I can get from it.
Yeah, that's fine. That's fine, Usman. Thank you.
All right. Thank you very much, sir.
All right, thank you Lord, for that presentation. The next group, please. Plotly, Ade Damola, Adesui, and Harry Prasad. Go ahead.
Good.
Can you see my screen?
Yes, but we can't see your presentation.
All
right, go ahead.
So good afternoon, everyone. Myself Hari Prasad, and here with me is Ade Adamoli, ADOC, and we are representing the Plotly group, and we worked on healthcare data analysis for anomaly detection. So coming to our topic, the healthcare analysis. Next slide, bro. So as everyone knows that there's many fraudulent happening within the healthcare in day-to-day life. So we have come across many data sets having the same rate for our information. We have got our materialistic practitioners and so yeah, the data acquisition. So coming to this, we have taken the data from the Centers for the Medicare and the Medicaid Services, the Office of Inspector General for the United States Department of Healthcare and Human Services, and we have made sure that it has been gone through a Social Security Act, and so that this data can be used for our process. So coming to our feature engineering. So these are the columns that we had in our data set, but as you can see that only few data can be used for this and rest have been dropped. So coming to our feature engineering, we came to know that the top 10 crimes have been committed due to by the insurance company to the management has been shown over here. The top 5 has been taken into our consideration, and we have trained the model with using this data. Next slide. The CMS data this containing has been issued by the providers. For memory reasons, we have randomly selected 110,000 data points contained in the data sets. The features are having where the specific type of service they are rendered, and the bar chart is shows the common rules in the data set, which has been generalized all over the world. Next slide.
So because of the crimes were recorded in statutory codes, we had to check for the meanings of these codes in the Social Security Act. So we found out that most of the most of the convicted healthcare providers were guilty of being unlicensed while practicing medicine. And our crime of interest, healthcare fraud, we found out that there were 4,500 convicts that were involved in healthcare fraud. So in our modeling, we started with the unsupervised learning, and it was isolation first we used. It has an hyperparameter called contamination that tells the algorithm what percentage of your data set to flag as an anomaly. So when it's 1%, it flags 1,000, 2%, 2,000, over 100,000 data points, sorry. So to use a supervised learning algorithm, we had to label our data sets. And we found out that there were only 17 true positives. We used random forest and logistic regression as our supervised learning algorithms. And when we wanted to evaluate these models, we used stratified cross-validation because of this disproportion in our data set. We found out that our isolation forest was inefficient in that of the 1,000 anomalies it's flagged, only 4 of them were true positives. When we added another 1,000 anomalies, only 1 of these was a true positive. The supervised learning algorithms too were unreliable in that they were unusually accurate. These results we got from the isolation forest. The blue dots are the anomalies. After the work we did, since the unsupervised learning algorithm was unable to find any pattern in our data set, and the supervised learning algorithm was overfitting our data set, we concluded that our features were mostly noise. Thank you.
Okay, so nice presentation. Yeah, I would like to ask one question. You said like the features are not enough for anomaly detection. How are you going to justify that, and like what would you do to overcome this?
Okay, we could the data points, like when we looked up what the people that were called fraudsters or people that were convicted for crimes, the things that we saw that they did, we could not, like our features could not bring them up. Things like some people paid other practitioners to refer patients to them, so that, okay, someone might not need a particular medical service, but maybe I'm a dentist now, I'll tell another person to say, okay, you have a bad tooth, so I'll pay him to refer this person so that I can get money from him, things like that. So our features were not enough to flag things like this. So given more time, we could search for more features. We could also increase the data points we used.
Okay, so is there any way like I can use your results so far in real world?
No, it's a basis for building a model. It's a starter, okay, for you to know, okay, this is a way that does not work.
Okay, yeah, thanks.
All right, thank you for that presentation. The next group, Boke, Yusuf, Miriam, and Matura Moshood. Are you ready? PyTorch, please. All right.
Yeah. Good afternoon, everyone. My name is Mariam Yusuf, and I'm presenting for Simboke. Okay, the topic is environmental health, air pollution in India. Okay. These are the group members that contributed to the project. Problem statements. Air pollution are majorly caused by pollutants that are released from automobiles and industries. So by analyzing data collected on the use of these pollutants, we can detect local trend and relate the air quality change to changes in environmental policies. Example of the pollutants that were that the data were collected are nitrogen oxide and sulfur oxide. Okay, the data were collected from Kaggle. The link is down here. Then these are the information about the data. We have city dates, particulate matter, and all. Okay, exploratory data analysis was done. So it was discovered that a trend was discovered on SO2 data that from 2015 to 2019, the quantity of SO2 keep on increasing till 2020, which it dropped. Also, a chart, this is a chart of particulate matter 2.5 data of the cities in India. So it was discovered that Delhi has the highest quantity of particulate matter. A chart of city was plotted against AQI. That AQI is air quality index, and it was these are the top 10 cities with the highest value of AQI. So Ahmedabad was discovered to have the highest AQI. Also, the second chart in this slide is the chart of the AQI buckets. That's like the AQI buckets. It was counted for all the cities and for all the years considered. Okay, moving to feature engineering and machine learning. This is how it was done. The AQI was used as the output, while the other values are used as features, the pollutants, the day, the month, and year. Machine learning, moving to machine learning. These are the 3 models considered. So these are their training sets, test score, the mean square log error, and the mean absolute error. And it was discovered that gradient boost, random forest regressor is the best. Although the 2 were not bad, but it was random forest regressor is the best. So what are the challenges faced during the course of this project is inactiveness of group members. Majority of the group members did not contribute to this. They need sufficient time to do more analysis on the project. And also lack of high quality data. If a more quality data is gotten, I believe the models would have performed better. Thank you.
All right, thank you very much. Over to the judges.
Okay, so next presentation. So my question is, so is it just analysis that you did? Did you try to see if you could like use machine learning, like build models?
Yes, we did. I mentioned we used 3 models. I'll try and go back to the slide. And this was the result that we got. We used random forest regressor, gradient boost regressor, and extra tree regressor.
Okay, I think I missed that. So that's all from my end.
Okay.
All right, thank you. Thank you for that presentation. The next group, PyTouch, Omotosho, and Daniel.
Yeah, good afternoon. Please allow Akonde Dockers to share the screen.
Akonde
Dockers.
All right.
Yeah.
Dockers, please go ahead and share your screen. Dockers, are you here?
Yes, I'm here.
Okay, please go ahead and share your screen.
Sorry, please. I'm trying to share. Can you see the screen?
Yes.
Okay.
It's still coming up.
Please, can you see the screen?
Still coming up, still coming up.
Oh.
Yeah. Yeah,
Have you
thank
seen
you.
it? Okay.
Yes, yeah.
Okay.
So good afternoon, everyone. Yeah, so my name is Omatosho Abdulmatin. I'm representing the PyTouch group. So basically, we are presenting the project Facebook AD campaign. And so these are the names of my team members. Next slide. Yeah, so introduction. Yeah, as we all know that Facebook is one of the biggest companies when it comes to running paid advertisements for people. So in this project, we are trying to build a model to help us meet our target audience better and also generate income. Next slide. So in the past years, marketing was not so effective because we did not have enough technology to reach our target audience. And many companies are looking for ways to reach people interested in their products. So with tools like machine learning and deep learning now in place, we have been able to tackle this problem by building a classification model to help us know our target audience for different Facebook AD campaigns. Next slide. So this data set was gotten from Kaggle. It consists of 15 columns and 1,143 rows. So the approved conversion column is our target issue, and it tells us if you are going to have an actual active users or not in a campaign AD. Next slide. So here we have some visualization. So in the first part, you can see the age group reaction to different campaign ID. So the first in the campaign ID 916, we can see that we have more reaction from people in the age group of 45. In the campaign ID 936, we have more reaction from people in the age group of 30 years. And then in the campaign ID 1000, we have more reaction. We have reaction from people in the age group of 30 years. So the second plot is showing the different genders reaction to different AD campaign. And then the first one shows that female have more reaction in the 916 AD campaign. Then in the 936 AD campaign, we have more reaction from the female. Then the last AD campaign, we have more reaction from the male. Next slide. So here we have an heat map that is showing correlation between some of the features in our data set. Next slide, please. So here we have a pie chart representing the gender and age analysis. So we can see that we have male in the age group of 30 to be occupying the larger part of the data set, then followed by female within the age group of 30. So the second plot is showing different age groups and the numbers in the data set. Like we have more people within the age group of 30, then followed by 45, 35, and 40. Next slide, please. So basic cleaning was done with Power BI. We removed some null values, then we did some feature engineering, then we converted all the categorical variables into numerical ones using the label encoder. Next slide. Next slide, please. So here we tried to split our data set into the train and test bits. Then we did some feature scaling using the standard scaler to make our model perform better. Then we train our model using the logistic regression yeah. And then we use the logistic regression, then we use the accuracy score to get the performance of our model. We have 72%. Then we use the randomized CV search to optimize our parameters so that our model can perform better. Next slide, please. So when we use the randomized CV classifier, then we're able to get an accuracy of 74%. Next slide. Yeah, so from the gender and age analysis, we can deduce that the campaign ID 196 and 936 have more reaction from females within the age group of 30 years. And also, we should also note that different AD campaigns should be targeted towards specific audience based on their age, gender, and interest. Why features like click, spend, impressions, tools, total, and approved conversion tell how efficient the AD campaign is. Thank you very much.
All right, thank you. Over to the judges.
Yeah, so Abdul Martin, sorry, what evaluation metric did you use? I'm seeing accuracy.
Yeah, accuracy score.
Didn't you like try making use of the precision and recall? Since it's a classification problem.
I think we use the conversion method to also. Please go to that, to the previous slide. The next slide. We use the conversion metrics also to know our model perform.
Yeah, can you like based on that like justify what you did, please?
Okay, please move to the next. To the next, I think, slide. Yeah, I think this. Yeah. So here we have our conversion metrics. Yeah. So basically, what this is telling us is that 77. Okay, for the first category, that is if we are going to have active users. So 77 times it predicts it as okay, we have 77 times it predicts it as we are going to have active users. Then 13 times it said the value should be that we should not have active users, but our model is predicting it to have active users. Then the second one is telling us that 88 times we are not going to have active users. Then 51 one is telling us that 51 times we are going to have active users, but our model is predicting it the other way.
That's for a nice presentation.
Yeah.
Thank you very much. And so the final group for this session, XG Boost. I hope you're ready. Sonali, Aurora, and Tamara. Please go ahead.
I am. This is Tamara Wamakina. I'm ready to present my screen. Okay. Hi, can anyone hear me?
Yes, please.
I don't know if you can see my. Can you see my slide too? Hello, can you see my slide?
Yes, we can see yours.
Okay. Thank you very much. Okay, so my name is Tamara Wamakina, as I said earlier, and I'll be doing a presentation on global food prices. So this is the name of my teammates. We have the collaborators and other members who were present to give their feedback as concerning our presentation and the project in total. So the problem statement. So the world is now a global village, and which means that market and supply chain can be global. So as a young trader, our model seeks to predict which market I could buy from aside my country. So I'm in USA and probably things are expensive at the same time. I can look for countries or localities where things are cheaper and buy from there. Okay. So this is our approach. We have the data collection, the data exploration, feature selection, model training, and model development. A brief description of our data sets. Our data set was gotten from Kaggle, as I said earlier, and it has columns showing the country, the locality, the market, good purchase, the price and currencies, and quantity exchanged.
It also contains data from 1982 to 2015. Places like the edge, a screenshot of data used. So we then did our data pre-processing and exploratory data analysis, where we're able to use the heat map, to see which values correlated, which values had high correlations. Then we also did a profile report to have an overview of the set, to know how many variables we have, missing cells. This is to help us with the pre-processing, and these are feedback of the profile report. So we also have country name showing high cardinality, high correlation. The next was the feature engineering. We're able to use our Pearson correlation and the univariate selection to determine features which would be used or which had to be used for our machine learning, and the ones that are most well, I say correlating, or the ones that have the most effect here, the most effect on our food prices. So this is the model training. We're able to use the interactions, the correlations, the heat map, and we also used the XGBoost regressor and the random forest to determine which, for our machine learning phase, determine which machine learning model works best for our data. So we started with random forest actually, and we started with random forest and we got a R2 square score of 0.838, and then we did the XGBoost regressor and we were able to get a score of 0.994, and because of that we didn't go further to see other models, because it already shows the R square score was already high enough. Then for our model deployment, our model was deployed using Streamlit, and and this is a picture of how it works. It impute your various parameters and is able to tell you the price of food in another locality for you to buy. Thank you very much.
All right, thank you.
Can anyone? Okay.
Like, nice presentation. One question. So your R square value was 99%. So
yes, sir.
Don't you have a thought like it might be overfitting of the data set?
So yeah, though we used it could be an overfitting, though we used a 0.3 test model. That was why we used 0.3, for we actually didn't explore that option of trying to see if we needed to reduce the. So we didn't explore. We didn't look at it that it was an overfitting. We just thought that it showed it was a very good score. It was predicting well. That's what we thought.
So do look at this factor of overfitting, because I think the model is overfitting. Also, you just tried 2 models. Okay.
Yes, sir.
Yeah, it's fine. Just one thing, like the data set is up to which date?
Sorry, I didn't hear you. What did you say? The data
set is up to which date? Up to which date?
Is what?
The last date of the data set. The last date time. What?
Okay, 2015. Okay, yeah, 2015.
Okay, so with that you are predicting the future prices.
Yes.
Okay, so essentially this can be a time series forecasting, right?
Sorry, I didn't get that.
So this can be a time series forecasting, right?
Okay, yes.
Okay, thanks.
Okay, thank you very much.
All right, thank you, Tamara. Thank you, everyone. It's been a magnificent session so far, watching presentations from our interns. And I'm sure you would agree that you've learned a lot from this presentation. I must greatly appreciate each one of you for putting work into this project and giving us here at Hamoye reasons to be proud of our work and effort. Kudos to the Hamoye team too. Thank you to our awesome judges who have given us their time and glimpse into their vast experiences, sharing brilliant ideas and notable counsels. We appreciate you all. Our Hamoye fellows have been outstanding too. And these people are a joy to be with, and it's a pleasure to have you join us today. We would like to have you join us in more of such presentations going forward. So if you're still wondering what the results are, and you want to know who the champion of this presentation is, we'll compute the results from the judges and have it published on Slack